My dear friends, welcome back to BSpice. In this session, we'll talk about the HVAC, heating, ventilating, air conditioning, types of control. So the last session we talked about the control basics, but this is about types of control. Okay, this is one type of control. I'll explain the in the subsequent slides. Okay, right. So types of control system. Direct acting system. This is one of the system. Direct acting system. So the simplest form of controller is direct acting, comprising a sensing element which transmits power to a valve through a capillary, bellows, or diaphragm. Okay, this is the direct acting system. Okay, so the measuring system derives its energy from the process under control without amplification by any auxiliary source of power, which makes it simple and easy to use. Okay. So most common example is a thermostatic radiator, which we discussed in the the previous, what do you call, topic, the control basics, right? So the radiator valve, which adjusts the valve by liquid expansion or vapor pressure. Okay. So direct acting thermostat have a little power and have some disadvantages, but the main advantage is individual and inexpensive, right? So the direct acting thermostatic equipment gives a gradual movement of controlling the device and may be set to modulate. Okay. So this is about the direct acting. Very simple. Okay. Now we go into the electric and electronic system. First, we'll start with electric control device. So electric control device provides on-off or two position. In residential and small commercial application, low voltage electrical controls are most common. So your transformer is used to reduce 110 volt AC to a nominal 24 volts. Okay. So the voltage is controlled by thermostat and can open gas solenoid valves. I think there is a typo error. Yeah, correct. It can open solenoid valves, energize oil burners or solenoid valves on DX cooling. Okay, this is nothing but direct expansion cooling actually. So if you want to know about this, also I can update you the direct what do you call DX cooling. So DX cooling or a direct expansion cooling is a type of air conditioning system used in HVAC. Okay. So in a DX system, the air is used for cooling a space is directly chilled by the refrigerant in the cooling coil. So that is the this one. Okay. So how it works basically, I think it's beyond the topic, but still I will cover this. See, there are four phases, right? See, one is, evaporation, compression, condensation, and expansion. So in evaporation, the refrigerant absorbs the heat from the indoor air as it evaporates in the cooling coil, okay? Cooling the air in the process. Then the refrigerant now in the gas form is compressed by the compressor. So that way increasing its pressure and temperature. Then condensation. So the hot high pressure refrigerant gas is then condensed back into a liquid in the condenser, releasing the absorbed heat to the outside air. Then finally the expansion. The refrigerant passes through the expansion valve, reducing its pressure and temperature before it re-enters the evaporator to repeat the cycle. So basically, this DX cooling is used in residential and small commercial building. Okay, so that's the point, friends. Anyway, that's now coming back to the subject here. So the voltage signal is controlled by thermostats and can open solenoid valves, energize oil burners, or solenoid valves on the DX cooling, and control electric heat, operate two position valves and damper or turn on off fans and pumps. This is electric. We are talking about electric. A relay or contactor is used to switch line voltage equipment with low voltage control signal. Advantage of electric system is that it eliminates the personal safety and fire risk associated with line voltage and allow these control wires to be installed by a non-electrician also without requiring any contact or other safety measures. So this is about the electric. So these systems are generally limited to on-off control and cannot operate at half capacity. That is not possible. So it's just on and off. Okay. Now we have an improved version, electronic. So the electronic control devices can be either modulating or two position, on and off, right? So electronic control usually have the following characteristics. As we know, controller, low voltage, solid state, right? and inputs especially 0 to 1 volt DC, 0 to 10 volt DC, 4 to 20 milliamps, resistant element, thermistor, thermocouple, all these, right? So output to 10 volt DC or 4 to 20 milliamps device. Control mode, two position, proportional or proportional plus integral, PA. And others, controllers can be remotely located from sensors and actuator. Controllers can accept a variety of inputs. So remote adjustment for multiple controls can be located together, even though the sensor and actuators are not. Okay, here I'm talking about the remote adjustment. Okay, right. So this is about the electronic. So electronic control can accommodate complex control and override schemes. These are some of the things. And of course, universal type outputs can interfere many different actuators, right? So to add on few more, display meters, it indicate output and input values. That is basically the display. And an electronic control system can be enhanced with visual display that show the system status and operation, all these. And many electronic controllers have a built-in indicator that show power, input signal, deviation, output signal, all these. An indicator light can show on off status, or if driven by the controller circuit, the brightness of light can show the relative strength of the signal. So all these are the available in electronic systems. Okay. So we talked about the direct acting and the electric and electronic. Now we go into the pneumatic, very famous. So the most popular control system for large building historically has been pneumatics, which can provide both on and off and of course modulating. So the pneumatic actuators are described in terms of the spring range, isn't it? So what are all the common spring ranges? 3 to 8 psi, that is 21 to 56 kPa, and 5 to 10 psig, which is 35 to 70 kPa, and of course 8 to 13 psig, 56 to 91 kPa. So compressed air with an input pressure can be regulated by thermostat and humidity state. So by varying the discharge pressure from this device, the signal can be used directly to open valves, close damper, and energize other equipment. We are talking about the pneumatic, right? So copper or plastic tube carrying the control signal around the building, which is relatively inexpensive. Okay. So to add a few more, pneumatic systems are very durable, safe in hazardous area where electrical spark must be avoided. Okay. And most importantly, capable of modulating operation at fault load condition, whereas there electrical it's not right. Yes, so that is the pointer. So while the 24-volt electrical control system could only energize a damper fully open or fully closed, the pneumatic system can hold the damper at 25%, 40%, and 80% open. And this allows more accurate matching of supplying the load. So that is the point of this pneumatic, sorry. So pneumatic control use clean, dry, oil-free compressed air both as a control signal medium and to drive the valve stem with the use of diaphragm. So it is important that dirty, moisture, and oil are absent from the compressed air supply. Right. So instrument quality compressed air is more suitable for controls rather than the industrial quality. Okay. And it requires, drying to a dew point low enough to satisfy the application. So main disadvantage with this pneumatic is, of course, less reliable and noisier when compared to the electronic system. So this is about the third type. Okay. Pneumatic. Okay. Right. Now we go into the final one, of course, not final one. This is a microprocessor. So this is what I mentioned in the beginning. So this is what the DDC control, whatever I put in the beginning first slide, right? That is a DDC. So DDC is nothing but direct digital control. This is the most common deployed control system today. Sensors and output devices like actuator relay used for electronic control system are usually the same as the one used in microprocessor. Sensor wise, no issues. Only the control part is different. So the distinction between electronic control and microprocessor system is in the handling of the input signal. So in an electronic control system, analog sensor is amplified, right? And then compared to the set point, right? Or override signal through voltage or current comparison and control circuit. In microprocessor-based system, the sensor input is converted to digital form, where discrete instruction like algorithm, it performs the process of comparison and control. So most subsystems from VAV boxes to boiler, chiller now have onboard DDC system to optimize the performance of that unit. So communication protocol known as BACnet is a standard protocol that allows controller units from different manufacturer to pass data to each other. So you may have a query on this here, right? What is BACnet? Yes. So BACnet is nothing but Building Automation Control Network, and the short form of a BACnet. So it's a communication protocol specifically designed for building automation. It's widely used in HVAC system because of its ability to integrate seamlessly with various HVAC equipment like chillers, boilers, air handlers, and variable air volume system. That's what I mentioned, right? VAV system. Okay. So what are all the benefits actually or key features of BACnet? Of course, interoperability. BACnet actually allows devices from different manufacturers to communicate effectively, simplifying the system integration and maintenance and data exchange. So BACnet enables the exchange of crucial data such as temperature, humidity, airflow, facilitating efficient HVAC operation and optimization. We should able to continue. There is some short, some signal loss. Anyway, so now we are talking about the BACnet, right? Yes. So the BACnet, as I highlighted earlier, it is for interoperability and of course the data exchange and fault detection and diagnostics. So BACnet supports FDD, that is fault diagnostics, fault detection and diagnostics, which helps to identify abnormalities, optimize the energy usage, and direct and detect potential fault before they cause a significant problems. And remote access and control. With proper security measures, user can monitor, adjust, and troubleshoot HVAC devices parameters from a remote location. So these are the benefits and of course energy management. So BACnet assists in energy monitoring, load shedding and demand response functionalities, helping facility manager optimizing the energy resources, energy consumption and reduce the cost. So that's about the BACnet, friends. And essentially this is about the microprocessor system. Okay. Now we have a mixed system. So mixed system in the sense it's a combination of control devices. For example, electronic controllers can modulate a pneumatic actuator. So that is the point. Additionally, the proportional electronic signal can be sent to a device called transducer, which convert this signal into a proportional air pressure signal used by the pneumatic actuator. So as we know, these are known as electronic to pneumatic transducer, E to P. So for example, electronic to pneumatic EP transducer converts a modulating 2 to 10 volt DC signal from the electronic controller to a pneumatic proportional modulating to 13 psi signal for the pneumatic actuator. A sensor transducer assembly, this total is called a transmitter. So the input circuit for many electronic controllers can accept a voltage range of 0 to 10 volt DC or a current range of 4 to 20 milliamps. So the input to these controllers are classified as universal input because they accept any sensor having the correct output, and these sensors are often referred to as a transmitter as their output or an amplified or conditioned signal. So here we are talking about the mixed. So the primary requirement of this transmitter, they produce the required voltage or current level for an input to a controller or the desired sensing range. So the transmitter measures the variable conditions such as temperature, relative humidity, airflow, water flow, power consumption, air velocity, light intensity. For example, transmitter would be a sensor that measures the level of carbon dioxide, CO2, in the return air of an air handling unit. So the sensor provides a 4 to 20 milliamp signal to the controller input, which can then modulate outdoor or exhaust damper to maintain acceptable air quality level. So since the electronic controllers are capable of handling voltage, amperage and resistance inputs, temperature transmitters are not usually used, not sued as controller inputs here due to their high cost and added complexity. So that's all about the things, friends, controls basically. Direct acting, electric, electronic, pneumatic, and microprocessor, that is DDC, and mixed system, friends. Thanks for your support and keep supporting and keep watching. Thank you. Take care. Bye-bye.